Hi everyone, welcome to a quick review of how to divide complex numbers. The basic process is a process that we call rationalizing, but essentially we're just going to multiply both the numerator and denominator by the complex conjugate of the denominator. Now I know that sounds a little scary at first, but let me show you the process and I think you'll find that it's not as bad as it sounds. So just a reminder, the complex conjugate, to get one of those, you just change the sign on the imaginary part. So if you had a plus bi, you now have a minus bi. So find the I and change the sign in front, and that's a complex conjugate. So let's take a look at an example. This is 3 plus 7i divided by 8i. So the first thing I'm going to do is multiply by negative 8i under negative 8i. So all I need to do is distribute this and then simplify. So negative 8i times 3 is negative 24i. And negative 8i times 7i is negative 56i squared. Now I'll multiply the denominator. 8 times negative 8 is negative 64, and I times I is I squared. Now, simplifying, you may recall in my multiplication video that I said cross out the I squared and change the sign in front. So I'm going to do that for both of these. Now, I should reduce this if possible. Now, reducing, if you notice a number that goes into all of these, like 8, which is the case here, you can go ahead and reduce by that. Another option is to split this up into two separate fractions and do 56 over 64 and reduce that fraction, and do negative 24 over 64 with an I next to it, and then reduce this fraction. So I'll reduce by 8. This is 7 over 8. Minus, this will be 3 over 8i. So you can write it like this, or since they both have the same denominator, you can write 7 minus 3i over 8. Both of these are acceptable answers. Okay, now you are allowed to not split it into two fractions. Just be careful with your reducing. When I see people do that, a lot of times they'll reduce the 24 and the 64, but they'll forget to reduce the 56, and then they'll get a wrong answer. So just be really careful with your reducing. Okay, let me show you another example. I have 5 plus I divided by 2 minus 4i. So I have to multiply by the complex conjugate of the denominator. So it's 2 plus 4i. I changed the sign on the I part, just the I part. Okay, and now I have to multiply by that in the numerator as well, because this fraction is actually equal to 1. So you're just multiplying by 1, so the value is not changing. So let's multiply. 5 times 2 is 10. 5 times 4i is 20i. I times 2 is 2i, and I times 4i is 4i squared. In the denominator, you may recall that this is a difference of two squares, which is the whole point of this. We want it to be a difference of two squares because when that happens, all the i's will cancel out and you're just left with a number. So the special pattern is that you square the first term, you square the second term, and write a minus sign in front. Sorry, in between. So 2 squared is 4. 4i squared is 16i squared, and the minus sign is here. Now we just need to simplify. So cross out the I squared and change the sign in front. Cross out the I squared and change the sign in front. So now for my real parts, I have 10 minus 4, which is 6, and 20 plus 2i is 22i. And 4 plus 16 in the denominator is 20. We should reduce this. So you have 6 over 20 plus 22 over 20i, and both can be reduced by 2. So this is 3 over 10 plus 11 over 10i. And again, you can write this as one big fraction, 3 plus 11i over 10. But just be careful with your reducing. Okay, so those are my answers. So let me know if you have any questions, and hopefully this helped.